Hey guys, so this video is on gene mutations or point mutations to follow on from our chromosomal mutations and still leading into evolution, looking at mechanisms of evolution. So the learning intention for this video is to understand the difference between a block and a point mutation, to know some examples of point mutations and to understand the impact that those point mutations might have. So a point mutation is defined as a mutation which affects only a small number of nucleotide bases. So we're not talking about real large scale changes. It's more about smaller number of base changes that might then have an impact. So you can see in the diagram, for example, a G changing to an A or a T changing to a G. So we're much smaller scale with these types of mutations. So mutations, some of the consequences, well, some can be detrimental and cause death in individuals. Others can be beneficial or start to drive evolution. We know evolution relies on some variation amongst the population, and mutations can cause that variation. So if we're thinking about a population of rabbits and they're all white, if we have a mutation, one of them might become black, and that might then lead to natural selection that might select for the black ones or select for the white ones. So mutations are really important in setting up some of our other drives of evolution as well. So there are three main categories of point mutations we're going to look at. There's substitutions, which is just replacing a base. We've got insertions or inserting an extra base, and deletions are removing a base. And obviously this little cartoon here shows that we started with a normal beast. Here's our substitution. Here's an insertion of a letter, and here's a deletion. You can see that it has an impact on what our final product is going to be. So the reason why base mutations are really, really important, or point mutations, is because the order of bases in DNA directly impacts on what we end up with as a result of transcription translation. So we've looked at codon charts and how they work. If we change the bases in DNA, it might eventually lead to a totally different amino acid and therefore a totally different protein being produced. So order is really, really important in structure of the DNA. And again, we're going to touch on the codon chart and how that might impact on mutations as well. So we'll start with substitutions. So this is where a base is replaced. Now this may or may not have an impact on the protein produced. And you can see here a simple substitution. We've just replaced A with G. Okay. An insertion is where we take one base and we add it to the sequence. And this usually then affects every codon after the mutation. So you can see here where between this T and G is, there's been a C inserted. And you can see that the impact is that all of these amino acids have changed after the point of where the insertion occurred. And so that would be an impactful mutation that might have a really negative impact on the organism. Deletions are much the same. We've got a base being deleted. And again, it usually affects every codon after the point of the deletion. So here you can see the first three codons are completely fine, but we've had a deletion of an A in our fourth codon. And now that means that the fourth, fifth, sixth, and seventh codons have all changed. We've made totally different amino acids. So it was meant to be his. It's now a different combination of amino acids. And that's going to have an impact on the function of the protein that it was meant to make. So those mutations, the three different types, can have four different impacts. And those impacts depend on how it changes the amino acid sequence. So we've got silent, missense, nonsense, and frame shift. So a silent mutation is when there's no change. So even though we've had a mutation, there's been no change in the amino acid sequence and the protein would be exactly the same. So you can see here, we've got CAA is being replaced with CAT, but the amino acid they code for is the same. And that means that there's going to be no change to this protein and therefore no change to, I guess, the functioning of what it does. And the reason for that, if we go back to our codon chart, is because sometimes we have an amino acid can be coded for by multiple codons. So if the mutation occurs and we get lucky, you can see that we actually have been lucky to still code for the same amino acid. A missense mutation is when we have a single change to amino acid. So here again, we've got a substitution. We've got A being replaced with C. And you can see A being replaced with C. But this time, that amino acid has changed from a glue to an ASP. So that then might lead to a functional change in the protein because the shape is going to be altered in some way. You can see that the other amino acids, they're still okay, but this one amino acid has changed, and we call that a missense mutation. The third one is when we actually make a premature stop codon. So again, we've had a substitution mutation. We've got a G being replaced with a T, but this time, instead of being glue, it's actually made a stop codon. So the impact of that is that the rest of the amino acids that were meant to be there are no longer transcribed and translated. And we end up with a much shorter protein. And so again, if it's a really, really short protein, it was meant to be really, really long, that's going to have a really negative effect on the functioning of that protein. If the stop codon was right at the very end, and we're only saying missing one amino acid, well, then maybe that protein still might work, but it's not ideal to have a premature stop codon. And the last ones are frame shifts. Now, these are normally caused when you have an insertion or deletion. We sort of touched on it a little bit earlier, is when we have an insertion of a base, it's going to then impact all the amino acids after where the insertion occurs, and same with a deletion. And so we would have a normal sequence. We've got these 5 amino acids, but because we've inserted a base, they've all been thrown off by one. And you can see that that's going to then change all the amino acids, whether it was an insertion or a deletion mutation to start with. So in review, DNA obviously has mutations, and the ones that we talked about were substitution, insertion, and deletion. And the impacts of those can either be a silent, missense, nonsense, or frame shift mutation. So point mutations are much smaller scale, but can have a pretty big impact depending on what type of mutation occurred and where it occurred. So I hope this video helped you guys go through point mutations.